Hello and welcome to the video about Pythagoras' theorem. And there he is, the man himself. And he was born about 2,500 years ago in Greece, and he's credited with discovering a very famous theorem about right angle triangles. It might not have actually been him, it might have been known 500 years before, but we're not too worried about that. We know it as Pythagoras' theorem. So what's it all about then? Well, there's a right angle triangle, and we must have right angle triangles. And the names of the sides are important, or the name of one of the sides really, and that's that one there, the hypotenuse. It's always opposite the right angle. See the arrow coming out of the right angle, and it's always the longest side. And the other two sides are known as A and B. They could be the other way around, B and A. It's not a problem. But the hypotenuse must be that long one, which is opposite the right angle. So, first little exercise. What you've got to do is identify the hypotenuse in each of these triangles. So, press pause, identify them, and press play again when you want to check. Okay, so let's check them. On that first one, there's the right angle, pointing to the hypotenuse. Second one, there we go. Third one, and what happens in exam questions is they do shift the triangle around a bit to try and confuse you and to sort of hide which one's the hypotenuse. But after this exercise, you're not going to fall for that, are you? There you go. So hopefully we got 6 out of 6. We know where the hypotenuse is. Really important thing to be able to do. So let's get our right angle triangle back. And let's name the sides. H for hypotenuse, A and B. Now Pythagoras' theorem is that h squared equals a squared plus b squared. Which means whatever number h is, if you square it, you get the same number as if you get the number that a is and square it and add that to the number that b is when it's squared. H squared equals a squared plus b squared. And we could write it the other way around. We could write it as a squared plus b squared equals h squared. And in some of the questions we do, we'll have to rearrange that one. And we can rearrange it to have a squared is h squared minus b squared, or b squared is h squared minus a squared. Okay, let's have a look then. So there's our right angle triangle. Now, Pythagoras' theorem is actually to do with squares like this. Have a look at these squares then. And what it actually says is that the area of this square is equal to the area of this square plus the area of this square. H squared is a squared plus b squared. But generally, we use it to work out lengths. And we kind of think of the formula as relating to lengths rather than to do with areas of squares, particularly in the work we're doing preparing for the exam. So we've got a couple of types of calculation. We're going to run through some of those now. There's the first one, when the hypotenuse is the unknown side. Now it's nice and straightforward. We just put values into the formula. So here is an exam question from the WJC from June 2010. Now there's Pythagoras' theorem. H squared equals a squared plus b squared, and we need to find the length AC. Notice AC is the hypotenuse. It's opposite the right angle. So we just write it down like that. AC squared is 3.6 squared plus 7.3 squared. And from here on in, it's just a matter of pressing buttons on the calculator. AC squared works out as 66.25. Now we don't want the area of the square, we want the length AC. So we need to take square roots of both sides. Square root of AC squared is AC, and the square root of 66.25 comes out to be that. And we've been given the length to one decimal place, so that's what we'll work to. So AC is 8.1 centimetres to 1 dp. So that's a nice straightforward one. Some exam questions can kind of try and hide it. So we've got this little story here about a speedboat race. Competitors are travelling 8.5 kilometres south, then they travel 7 kilometres east, and then back to the start. Calculate the total distance the competitors travel in the race. What they're really saying here is work out the hypotenuse of this right angle triangle and then add up the 3 lengths. So remember Pythagoras' theorem, h squared equals a squared plus b squared, and the hypotenuse is opposite the right angle, so that's that one that we don't know. Let's call the start point S, so then we can give some titles to the sides. So we're going to call that long one there SB squared, that's the hypotenuse squared, and that equals 8.5 squared plus 7 squared, which is a squared. plus b squared. Plug in the numbers to a calculator, we get sb squared is 121.25. We don't want sb squared, we want sb, so we square root both sides, and sb comes out to be that, and we're going to work to 1 decimal place. That's 11.0 kilometers to 1 decimal place. And remember, the question was find the total distance. So the total distance is 8.5 plus 7 plus 11, which is 26.5 kilometers. So it's just kind of hidden a bit. There's not a nice little triangle drawn and they say work out this. They try and confuse us with a little story, but we're not going to fall for that, are we? Excellent. Let's have a look at type 2, when we know the hypotenuse and we've got to work out one of the other sides. There's just a little bit of rearranging in these. So remember we had a squared plus b squared equals h squared. Well, we're going to rearrange that perhaps to a squared equals h squared minus b squared. Let's have a look. It's easier to see in an example. So there we go, a nice triangle. We know the hypotenuse. Okay, and we don't know x. So we're going to use a squared plus b squared equals h squared. That's Pythagoras' theorem. And we'll write them in. X squared plus 8.4 squared equals 9.2 squared. So this is just an equation, and we want anything with x on its own. So we're going to rearrange to get a squared equals h squared minus b squared by moving that little thing there, 8.4 squared. Over you go. You change to a minus. We could view it as moving and changing a plus to a minus, or subtracting from both sides. So anyway, whatever way we do it, x squared is 9.2 squared minus 8.4 squared, which comes out to be 14.08. Square root both sides. There it is. And they've given us the lengths to 1 decimal place. So we'll give them an answer to 1 decimal place. 3.8 centimeters. Okay, let's do one more. And we've got another little story one here. We've got a ladder resting against the top of a wall. The ladder's 4.9 meters long and the wall is 4 meters high. How far is the bottom of the ladder from the base of the wall? Well, let's fill in what we know. The wall's 4 meters high. So there we go, 4 meters. And they want us to work out that distance there. We'll call that x. So we've got our right angle triangle, and we know the hypotenuse because the right angle is pointing to 4.9. So we're going to use a squared plus b squared equals h squared, x squared plus 4 squared equals 4.9 squared. We're going to take that 4 squared across, so we're actually using Pythagoras' theorem in that form. A squared equals h squared minus b squared. That's what we're moving. Plus 4 squared becomes minus 4 squared. Work it out on the calculator. We've got x squared, we want x. Square root both sides. And the square root of 8.01 is that. They've given us a length to 1 decimal place, so we'll work to 1 decimal place. So x is 2.8 meters to 1 decimal place. Okay, sometimes we've got to do a little bit of work to get all the lengths in the triangle before we can use Pythagoras. And here's a good example from a WJEC paper from 2015. So they're telling us the area of the rectangle is that. They're telling us that the length ED and DC is that. But we've got to work out the area of the triangle and the length of BC. Now, once we see we've got to do some work on that triangle, we think, oh, it could be Pythagoras. It's a right angle triangle. We're dealing with lengths. But we need to know something or find out something first. So what they're telling us is that the area of that rectangle is 3,900 centimeters squared, and that length ED is 75. So actually, we can use that to find out the other side of the rectangle. Okay, so we know the area is 3,900, and the area is 75 times BD. So 75 times BD must be 3,900, which means BD is 3,900 divided by 75, which is 52 centimeters. So now we can say that one is 52 centimeters. And that's the end of us using the rectangle. We're now concentrating on the triangle. So it's clear all that out of the way. We want the area of the triangle. Well, that's half the base times the height. Half times 25 times 52. Plug that into the calculator, we get 650. And then the length of BC. Well, that's a Pythagoras theorem question. And it's a nice one because we're finding out the hypotenuse. Note the right angle is pointing to BC. So we can say by Pythagoras, BC squared is 25 squared plus 52 squared. Work out all that. 3329. Square root both sides. BC is the square root of 3329. which is that, and we'll work to 1 decimal place, 57.7. So a really good example there where we had to do a little bit of work on another shape to get the length we need to get the answers for the triangle. Let's put the answers in there. Job done. Now what you've got to do is go and practice, practice, practice. Loads of questions for you to have a go at. And good luck with them and enjoy them. It's bye for now.